Hello everyone and welcome to the first module of software engineering. I'm Dr. Sandeep Das, assistant professor in the Department of CSE, and I'll be taking your software engineering subject. In today's lecture, we'll be covering the basic of software engineering, and we'll also focus on few fundamentals that will be required in the understanding of this subject. So before we start, we'll look into the outline that this module will provide and what we are going to learn today. So there will be models and these models will be discussed in very detail that how our software process is being developed. And then we'll go into understand about software project planning, its analysis, its technical feasibility, and finally, we'll end with the cost benefit analysis using a COCOMO model. So before we start with this subject, let us understand what does these two uh, words, software and engineering, means. So software is more than just a program code. It is actually a complete set of executable instructions, associated libraries, and documentation. Documentation is a very essential part which most of us exclude while understanding or while writing codes. But it plays a very important role while designing our software product. So when a piece of software is developed for a specific requirement, we call it a software product. And the process, how we are developing it, or the code that we are using or the models that we are using, are we following a scientific approach or are the methods feasible both technically and economically? This aspect is looked by the engineering part. So together, this is known as your software engineering, where software looks into the programming aspect and engineering looks into the application of scientific principles and methods to design and build these systems. So in our context, it means applying these principles to build software that is reliable, efficient, and maintainable. So before we go into the depth of the different models and how they apply, let us see how IEEE, which is an international body of electronics engineers, how they define software engineering. They define it as a systematic, disciplined approach to a software development and maintenance. According to Fritz Bauer, a German computer scientist, he has defined software engineering as the establishment and use of sound engineering principles in order to obtain economically software that is reliable and work efficiently on real machines, not computationally, which will be fast, computationally, which will be feasible, and also reliable while it is working. So let us look into the evolution of software and what does it mean. So while designing or developing a software product using these software principles, uh, what are the steps that we follow? What are the different aspects that we look into, and how we look into it, how these steps are followed, refollowed, and redesigned is how a software is evolving. So it's not like that we just take on a problem. We just decide, oh, we'll be writing this with such and such codes, let's say C or C++ or Python, and our product is done. It's not like that. It is actually goes through lots of steps, lots of planning and analyzing, or we can say the journey takes a lot of steps and goes through processing and reprocessing to understand whether the software that I am developing is going to meet the specific need for which we are developing it. So first is the steps that comes in the software evolution path is the request. So a request comes from it can come from a particular individual or from a company or from some client who who has a specific requirement, and uh, and this comes to a software designing team or a company who develops the software. So both of them has a discussion, and a formal proposal of this plan is taken into account. After this team understands what are the requirement of the client, then it goes to impact analysis. Impact analysis means an assessment of the potential consequences and what it can be done, what it can be achieved, or what implications can happen, are completely analyzed in this phase. And once this is done, then it goes through planning and scheduling and processing, coordinating with the deployment software changes, and it is known as the release planning. Once this release planning is done, then it goes to the implementation, or say we can also say that the implementation in changes in the implementation, if the software has some changes, and finally the system is released to the end user. And while it is released to the end user, it may happen that this end user may face some bugs or issues while running this software. So it goes again to the first step, that is the request, where now this request acts as a change request, or a issue is reported in the software which has been released, and the team now looked into the impact of the issue that is happening or that is causing in the software. So now it goes into a loop where the first request from the client turns into a change request where the software will be now modified or where the bugs will be eliminated. And then it goes again to the impact analysis to understand what are the impact of these bugs or issues that have been caused in the software. And then these bugs are removed, and then again the process goes through this release planning and the deployment of the software after removing these bugs, and the change is implemented, and finally it will be released to the end user. So this is the part or the process where every software goes through, whether it is being released for the first time to the end user, or it is already with the end user and they are being updated or being reported for some issues. So these are the main parts of the software evolution where right from the beginning of idea and writing the code and to the implementation, this software is evolving. Now let us look into the software paradigms. So what does software paradigms mean? So software paradigms actually defines the approach taken during a designing part of the software and the development. It can be categorized into three parts. A software development part, where generally the software designing team gathers the requirement or understand the requirement of why a requirement of the client, why a software is being designed, how they can design it, what kind of programming they require for the type of software they are going to design, which programming language will be suitable, and what approach they must use that will be suitable for the development of the software. So software development part looks into this engineering concept. Then comes the designing part or the software designing part, which includes the designing, maintenance, and programming uh, of the requirement after the requirement. So once this requirement gathering is done, once the idea is being taken, now it will be conceptualized and implemented by the software designing team, where they will design the software They will maintain the software after the development, and they will do the necessary coding of the program. After this comes the programming paradigm, where uh, it is related closely to the programming aspect of the software development. Now, this is the place where the team is actually writing the codes, testing it, and they are dividing the codes in terms of into by different modules. So they break a large software into smaller modules, and these smaller modules are developed by different teams, and these teams will do their part, complete their part, and then finally it will be integrated and completed into a complete software. So this is how this software paradigm is working. So first one is the software development part. Second one is your the software designing part. And the third one is the programming paradigm, where we are actually doing the programming and designing the concept, or completing the concept. So now moving on, we will be trying to understand that what are the different cycles of our software development. So software development follows a pattern, and it is each and every software development model will follow the same pattern or same steps. Finally, they are implemented or deployed. So first comes is the planning. So planning is very necessary in case of software. So this stage is the first stage where we identify the scope of the project. We understand that what does this project or this software wants to do, what are its point or goal that it want to achieve, and then after understanding its goal or its requirement, we design a project plan. And once this is done, then we go on to analyze what are the requirements by the software team, and what will whether this project that we are going to develop actually has a market or not, what are the user feedback, or we can also gather information from the user to identify whether the project has some technical feasibility or not, and what are the improvements also we can do. So at this stage, we are actually trying to understand what are the requirements to develop the software, and what should we do to make the software better. It may happen that we have thought some idea, or we have conceptualized an idea, and that idea may not have a market. So designing such an project or such a software which doesn't have a market is not feasible. It is very essential in our part, or it gets very important on our part to understand whether the software has a market or not. So it is very important that the market research by gathering user feedback is done effectively, because it will actually make our software technically feasible and also acceptable in the market. Next comes the designing part, where the software architecture and the user interface are planned and created during this design phase. Here, actually, we discuss about the flowcharts, the designing documents, how we are going to design the software, what should be our approach, what kind of databases that we are going to use. So this is what where the design team comes into play. Mind it, this is not in this designing part. We are actually not writing the code. We are actually conceptualizing the idea in the form of design. That means what our software is going to do. We are conceptualizing it using different design. Later on, when we go into the depth of the subject or other modules, we will look into the designing aspect of the software design very depth or at a very depth, or we'll go into detail what are the different designing technique of a software. Once the designing part is over, now it goes to the programming team, where according to the design, the programming team or the design or the coding team will write the actual code. So what happens is that it may contain of multiple groups who will handle different modules of the software. Each module will have their definitive functions, and they will look design those each module, and finally it will be integrated into a functional and bug-free uh, software. Next comes the testing part. So once the once this coding team has completed their coding and designed the software, now it will go to the testing team, where the testing team will run some bug tests to make sure the software actually works well, and it will go through different bugs, and it will withstand a different test, and make sure the software uh, is ready to be deployed to the client side or to the users. Now, once the software which is designed by the coder goes to the testing team, passes the testing phase, now it will be ready for deployment, and and it will be released to the end users. Once it goes to the end users, now the while the end users are using this software, these users may report different kinds of bugs or fixes or requirements, or kind of upgradation that they may feel that it could have been better if something has been done in this way. So these are all will be part of the maintenance scheme, where the user feedback will be collected, user bugs will be collected, user recommendations or enhancement will be collected, and it will go back again to the designing team or the coding team, where they will try and fix the bugs, or they will try and improve the features or add new features to make according to the criteria or according to the suggestions of the end user. So this is the seven stages of any software development cycle that a software goes through. And right away, when we move into different models of software designing, we'll see all these software development models are actually following these seven stages, might be in a different approach. So each and every model will have their own approach of designing a software and taking a project and completing it. It depends that which project suits which model. So there are multiple models. Each will be helpful for certain kind of projects, but all these models will follow this software development life cycles, which has these seven stages, might be in a different order that this model will follow. So in next slide, we'll look into the software development models which are available. So these are the six models that we are going to discuss in this module. So we have waterfall model, we have prototype model, we have rapid action development model, we have evolutionary model, we have incremental model, and spiral model. So these are the six models in general. There are other models too, but we will be focusing on these six models. Out of this, waterfall model is the basic model that we develop, or that we will discuss to understand how these things work. And in next class, we will be discussing other models also. So let us go through this waterfall model, which is a very linear and sequential approach to develop any software. It has all the phases of the SDLC, which functions in a very linear manner. So when the first phase it's finished, then it will go into the next stage, and when the second stage finishes, it will go into the third phase, then it will go to the fourth phase, fifth phase, and so on. It will carry. So first phase of the waterfall model is the requirement gathering, where it gathers different requirements from the stakeholders or the clients and understand what the clients actually need to achieve in the project. And once Okay, so this is the requirement gathering where the requirement regarding these different software requirements or the what the client wants or what kind of detailing they need, what kind of features they need. These are all gathered from the client or the stakeholder to understand what kind of software will be designed. Once this requirement has been gathered, then it goes to the system design part where these requirements are analyzed, and depending on this analysis, what kind of hardware and software specifications, what kind of system architecture will be required is being conceptualized. Designing system designing is actually same as the design part of the SDLC life cycle. Once this design is the designing part is over or the designing phase is over, then it will go into the coding part where the actual code based on the design documents will be used to develop the software. Once this phase is done or the coding part is developed, then it will go into the testing team where various components and modules will be integrated together and will be they will test the entire code or entire software to identify and fix any kind of defect. So in case if defects is found, it will be not going back to the coding team, but it will directly go into the next stage where the implementation will be done. So this is one disadvantage what a waterfall model has, because it doesn't go back into the chain or back into the back into the phase from where it has come. It will go only into the next stage. One stage, when one stage is finished, it will go into the next stage only. So once the testing team finds some defects, it will try to fix it there. If it cannot fix it, it will go into the implementation phase. It will go to the implementation phase means it will go to the end user. It will be deployed to the end user. Once this end user gets this, they will face some bugs or face some issues which will be reported to the maintenance team, and then the maintenance team will take these bugs or issues into account, and then finally it will send it to the coding team where the bugs will be fixed. So this is how this waterfall model works. Very simple, similar to the SDLC life cycle, but the only thing is that once one phase finishes, it will only go into the next phase. It will not go into the backward. So it is only moving forward and in a linear and sequential fashion. So what are the shortcomings of this waterfall model? It is inflexible. Flexibility means we cannot make any changes when the project is going on, or because it will go from one phase to another phase. It will not go back. The testing becomes very late because it is in the development phase, and it makes very costly. So the stable requirements becomes very delay since we complete and the refinements and the requirements are not done properly. The customers are not involved properly because the customer usually only involved at the beginning and at the end. In the middle, none of the prototypes are shown to the customers. So whether the software is meeting the needs of the customers, they cannot understand or see until and unless they see a finished product. So it has risk, it has high dependency on the initial requirement. So suppose for an example, a client comes and he is not clear about what he requires, or he has some vague idea. So those vague idea becomes the requirement gathering in the first place. And by understanding that vague idea, a software developer will develop the software which may not be the actual thing what the client is wanting. So it has a very high dependency on the initial requirement, because in the middle, when the software is being developed, it is not shown to the customer or the client, which makes a very risky system. So this is it for today. Thank you for attending the lecture, and we'll be discussing another model of this software development in the next class. Thank you.